Okay. Now, as far as negative and positive correlation goes, you just need to set it up. Now, that's all I'm going to ask you. I'm not going to ask you about the correlation coefficient and all that stuff. If you have a graph, and that graph has a bunch of scatter plot on it, a bunch of data points, these are supposed to be dots. You're supposed to take a straight line and you're supposed to mediate it through all of those points by just eyeballing it. Okay? And when you do that, in this case, you're going to be putting it about right through here. Okay? Now, what I tell students to do is put your little car on the left side. There's your car. Looks like a weenie car. There's your car. And why do you put it on the left side? Because we all read left to right, unless you're from the Middle East, Musalama. Musalama is when you read from right to left. So unless you're from the Middle East, most of the time you're going to put the car on the left-hand side. Now what is that car doing? It's going downhill. Downhill is negative. So that's a negative correlation. Same thing with the positive correlation. If I give you a bunch of points, and I tell you to draw a line through those points, you're going to look at it and you're going to say, okay. And you take your car and you put right there, you've got a what correlation? Positive correlation. And that's how you know the difference between the negative correlation and a positive correlation. No correlation would be a horizontal line and that would look something like this. Oh, I'm supposed to use straight lines here. My bad. And a horizontal line is no correlation. So if you put a car on that line, that car is just going to what? It's just going to sit there because you have no slope. Now they're not going to give you anything tricky on these. They're going to just give you one of these three. Because that's what I'm going to pick, because I'm not going to give you one that might have a 1 degree off of horizontal. I'm not going to give you anything like that. There'll be one of these questions, one of those three. Is that what it was asking?
Yeah, but it didn't have to have it was like words.
They're probably asking for the correlation coefficient. I don't know, but I'll look. Did you send me the question?
No, I figured them out myself, but I thought, well, if this is actually what it's on the test, then I know.
It won't be, but I'll look at your. Well, I can pull up your question.
I can see the question.
Okay, well, I'll look it up if I can pull it up. Hold on.
Yeah. The altitude.
Latitude.
Yeah.
Well, I'm trying to pull up the grade book. And nothing's coming up. There we go. Which section of homework was it? You're doing exactly what I told that the students would do. Yeah, I just wanted to go over a question. What number? I don't know. What section? I don't know. All you had to do was send me a question.
Okay, well, I'll send you a question when I go home.
Don't forget it now.
No, it's not going to be E because we only have 4 questions in this class.
5C?
Yeah, Yeah, I did section 1 before I realized we didn't need to do section
7. No. Now y'all see why I get y'all to send me a question. So I don't have to spend all this time right now. It's been going on 5 minutes. So it must be the other section of
We'll
homework.
discuss it tomorrow then.
No, we're going to discuss it now. You brought it up. So it must be the other section, A? Or do you think it's E?
Well, that's it. That's it.
The following pair of variables state the units that might be used to measure each variable. Then state whether you believe there is 2 variables are correlated, if you believe the heights and weights of 50 randomly selected females between the ages of 1 and 21. So that means, we'll take your handy dandy virtual whiteboard and make it a transparent board. And you're going to straight line. I'm just the heights and weights of 50 randomly selected. So you can make this height and you can make this weight, or you can make this weight and make this height. But I'm going to put height because that's usually, I don't feel like changing right now, so I'm just going to put an H right there and a W right here. And let's say you got a between 1 and 21. Well, all your 1-year-olds are going to be what? They're going to be right in here somewhere. And then 5, 6 years old is going to be right in here. You're not going to see somebody get short. Okay? Nobody gets short unless something bad happens. Okay? So most people are going to be progressive what? Increase of. Now, with bone mass as well as muscle, if you get taller, chances are you're going to what? Yeah, nobody gets taller and loses weight, okay? Unless you're in a very where you don't eat and then you get skinnier, all right? I'm just, there's outliers and everything, okay? There are some people that go from 50 pounds and then they start getting tall and then they go down to 40 pounds, okay? There are some people that do that, not many, all right? So you get up to 18, you're going to get a little bit taller and you're going to be a little bit wear, and then you get up to 21, and then of course after 21 you shoot up here. No, I'm just kidding. Oh no, 21 you get over here, weight goes up but the height doesn't. No, I'm just kidding. So what kind of correlation is that? It's going to be positive. There is a positive correlation because pretty much as your height goes up, your weight is going to go up also.
So pretty much you're using line the graph.
Yeah. Mm-hmm. Now the next one. Okay, that's the same question. I'm looking for the one where you said gasoline or something. Gas mileage.
Yeah. Yes, and I had one because I didn't have to see the question.
Okay.
It's the same thing.
Okay. Well, here's one. Wait a minute, I'm trying to erase it. All right, now that one, you draw a line, that one, and I'm trying, people, I'm trying. It's just been a rough morning. Go away. And you could almost be, no, you can't do that because of this point and this point. You have to kind of go with those 2 points. So I'm going to draw a line like right in there. So there is a positive correlation. This is, you could say a week. but I usually look at your left one and your right one. Well, actually, this one is your right one, so you need to bring that one down because this is the furthest one to the right, so I was incorrect. Right there. Because you got to separate between these two right here. So I would say a weak correlation, but there's a positive correlation. And the reason I only gave you 4 on these is because that's how many questions you'll probably have on the test, and I'll just pick one of them, and you'll be answering one correlation question. Okay? So, yeah, the best thing to do, usually, you got to visualize it. You can't answer it just from a paragraph. You have to actually visualize it. So, good question, even though I had to spend 20 minutes to find it. You know, there's an easier way to do that. You hit a button and ask my instructor.
I'll before and you instructor didn't answer. So.
When did you do that?
Not you.
Oh,
not
okay.
You. That other math teacher I had.
Well, not all math teachers are as good as I am, all right? You got that?
So
okay, everybody was supposed to laugh, but y'all ain't going to interact with me, so bump y'all. Ha ha ha.
Oh, my goodness.
It's all right. I can bring Dr. Goodbody in here. He'll fix y'all right up. Dr. Goodbody.
He was here when my mom was here. He really was.
He still is.
She loved it. She did.
He's got like 90% failure rate. All right, let's get back to our chapter 6, and I can't. Let's see if I can pull up anything with chapter 6 since I wasted all that time. Since it took up all that time looking up stuff. There is course tools, and I'll try to pull up. We'll try to pull up the chapter contents again, chapter 6, and then nope. Who's got a book? Anybody got a book? Let me see. I'm gonna have to borrow your book. Yours might be some kind of, yeah, it might be some kind of disease or something. So it's not helping you out too much, but you can. I better not use it. I might catch a cold or something.
He's got a fancy.
Yeah, he's got a fancy book. Hardcore. All right. So chapter 6, we're looking at test scores, outliers, characterizing. Give me a second. Okay. Now, when you're talking about the statistics. You're talking about pulling up data, and you're talking about calculating, you're talking about putting it in order. That's the first thing. Put your data in order. Okay? You're going to put your data in order. You need to find the mean. The way that you find the mean is you add up all the x's and you divide by n. And now all of us have done this, finding your average of your test scores. You add them up and divide by 4. Add them up and divide by 10. However many test scores you got, that's what you get. Now there's some other things that you need to be able to do. You need to find the mean, you need to find the median, you need to find the mode, you need to find the range, you need to find the mid-range, the variance, and the standard deviation. Now, the two most important numbers in statistics Can anybody tell me the two most important numbers? The mean and the standard deviation. I don't care where you are. I don't care what career choice you pick. Those are the two most important in any career, any kind of, if you're in nursing and you're trying to figure out how many people made it on your floor and how many people didn't, you're going to go with the mean and standard deviation. That's what you're going to go with. I don't care if you're in Michelin and you're working at Crystal Palace up there on 85 and you're trying to find how many tires were made by Sandy Springs and Anderson and how many were defective. You're going to be speaking in terms of standard deviation and the mean. The mean and the standard deviation are the most important two numbers. What is the mean? Well, if I asked you what is the mean, you're going to say, oh, well, that's the number, you add them up and divide by it. Nobody can tell me what the mean is. The mean is the number that represents no deviation, no variation. So what does that mean? Well, let's say I give you a graph. And 5, 10, 5, 10, 15, 20. And you got a bar that goes here, you got a bar that goes here, you got a bar that goes here, and let's see, you got a bar that goes, and I tell you that I want you to level the playing field. Then you're going to take this guy and cut it off and going to put X's across here. And you're going to jerk him out of there and put him right here. 5, 5. And I jerk him, in other words, take him out. That leaves this guy, and I peel him off, and I put him right here. Okay? What have I just done? I've made no variation. This guy is gone. Okay? He's gone. And this number, 10, represents no what? And that's what the mean is. The mean is the number in all of the class that says, okay, at this number, there's no variation. So if I give you all a test right now, and it's 10 questions, and they're very easy questions, and the mean is 80. Okay? That means that at 80, everybody is level. That's what it means. So that's the description of the mean. This is the formula for the mean. The mean is the most important. It's also called average. Okay. It's also called X bar. In this class, it's going to be called X bar. Because it's a statistic. Statistic is a statistic of the sample. It's X. If it was a parameter for the population, it would be called mu. Mu, that's the population mean. It's a parameter. It's a Greek letter. Greek letters are population parameters. Letters are statistic, sample statistics. Now, what is the median? Well, think of the road. What is the median in the interstate? The middle. Now, why is that important? Because, no, not middle. We're not going to use the word middle. We're going to use the word center. Center is important in statistics. Now, what does that mean? Well, there's a thing called the mid-range. There's a thing called the median. There's the thing called the mean. All of those center around center. All of those have a tendency to be toward the center. The center tells you everything in statistics. The closer those numbers are the mean, the median, and the mid-range. The closer those numbers are, the more tight your data is. What? Tight? Tight. Meaning valid. The opposite of tight is sloppy or loose. Okay? And that means the data is not valid. This is when I give the bearing speech. Okay? In a bearing, if a bearing and a, usually I just pull it up. Let me just, I'm not even going to try to explain it, but hold on a second. Dang old. Bearing and axle. Any of you ever been in a plant before, or mechanical, anything mechanical? Find a good picture that you can see. Here's a good picture. All right, there's the bearing right there. See the bearing? And here's the axle. Now, let's say this is a roller in an industry plant. I don't know, Jacob's Chuck or assembly line or something. And that roller, BASF or first quality, and that roller turns 2,700 RPMs. What does that mean? Revolutions per minute. That thing's going fast. All right, 27 RPMs. That's pretty fast. And what if that bearing was to go out? Well, then that bearing is on a bearing housing, and that bearing housing is on a foundation to where you got 2 bolts on it, and it's bearing housing, it's bearing down, so that won't move. What is tolerance? Anybody know what the word tolerance is? How much it can take? Yeah. But it's also, in terms of mechanics, it's how tight something is fitting. Something fits. The tolerance between the axle and the bearing is very tight. In fact, you have to take a mallet, a rubber mallet, and you have to drive that axle pretty much in that bearing. Why? Because the more tight it is, the less it's prone to be sloppy, okay, or untight or loose. What happens when it gets loose? Or what happens, let's say that the guy replaces the bearing and it doesn't fit exactly right, but it's okay, nobody ever knows it. And they'll put it in the housing and they bolt it down. What's going to happen at 2,700 RPMs? It's going to start doing this. And then after a while, about a minute of turning 27 RPMs, it's going to start doing this and this. And then what's eventually going to happen to the bearing? It's going to be torn out by the axle. All right? So the more tight the bearing fits on the axle, the more use you're going to get out of the bearing and the axle. So the more tight your data is, the better. The more loose your data is, it ain't going to do you any good. All right? Just like a loose bearing, you might as well not even put it on there, because in about 10 minutes, it's going to heat up and it's going to tear up your bearing housing, it's going to tear up your axle, it's going to tear up all that stuff. Okay? Tight, good, valid. Loose, sloppy, not good, not valid. So, what tells you whether you've got a tight fit on your bearing or whether you've got a tight fit is your mean, your median, and mid-range. Those 3 things. And I'm talking, you have to look at your data and see how spread out your data is. If you've got, let's say that your middle number, your bottom number is 3 and your highest number is 52. And you got a mid-range of 24, your mean is 26, and your median is 27 or 25, then your data is tight. In other words, there's not a lot of outliers. Outliers, dang old 6-foot second graders, all right? 1,800 SATers in the 9th grade, all right? Those people that just throw the norm, throw it out the window, it just gets it all crazy. That's an outlier. So when you're finding all this information out, and you get this guy, and you get this guy, and you get this guy, and you look at them, and they're out of Wampus. If they're out of Wampus, then you got invalid data. You got a lot of outliers. Out of Wampus is, you know what you ever washed towels before? And some of your towels get on the side of your washer. What does your washer do? Womp, 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 womp. Out of Wampus, out of balance. Okay? That's what happens. And if these three don't line up, then you got a problem. You got an outlier. It's loose. It's not tight. Capiche? You got to let the numbers tell you what's going on in statistics. You can't just sit there and say, okay, the mean is 25, the mid-range is 24. What do I do now? You got to let the numbers tell you what's going on. And that's what happens. The median. How do you find the median? Well, let's look at it. Let's do that on the next page. The median. If n is even, find the average of two middle numbers. If n is odd, you just find what? Find a middle number. Now, I'm not going to insult your intelligence by doing a lot of these, because I think most of you can tell if n is odd or even. I'm going to do 2. 24, 25, 25, 30, 31, 32. N is the number of numbers, so we'll count. 1, 2, 3, 4, 5, 6. They're in order. Make sure, always, everything's got to be in order. And then after you put them in order, you count. 1, 2, 3, 4, 5, 6. So you've got to find the average of these two numbers, which puts the average right there between the two middle numbers. Okay. So that's how you find so 25 plus 30 is what? Divided by 2 is equal to 55. Divided by 2, well, half of 50 is what? 25, and then half of 5 is 2.5, so that would be 22.5. So 22.5 is your mean, the median of those numbers, that data. I'm sorry, 27.5. Okay, everybody's supposed to say, I got 27.5 after I found out that I made an error. Everybody say it. Now you're supposed to say it like I'm a damn fool. All right? Yeah, I got 27.5. I love it when y'all do that. Y'all wait till after I, commit myself. And then after I commit myself, y'all act like that I am the dumbest person in the world.
No, you're not supposed to make mistakes.
Whatever. Oh, that's the next thing. I was wondering. Yeah, I was wondering what happened.
I'm stupid.
No, I'm stupid. Because that's what y'all are supposed to do. I got 27.5. Okay, people, I make mistakes, all right? I'm doing this in my head, all right? I make mistakes. All right, now let's do another one.
You're doing a good job.
24, thanks. I'm going to go put smokestacks on my truck because I feel very bad right now about my self-esteem. 26, 26, 30. Now, there's 5 numbers. And what do you do with 5 numbers? You just find the middle, and there is your median. Okay? That's what's wrong. I had to take my truck this morning to the paint shop, so I don't have my truck. I'm driving around in my mama's Mountaineer that smells like the stinking dogs of hers, which I'm going to Perks afterwards. They're going to clean that car up. I ain't driving around in a car that smells like a stupid dog. That's why I like cats. Cats don't stink.
Cats are weird.
No, they're not.
Yes, they are.
Listen, if you're a good human servant to a cat, there's no problem.
I mean, there is a problem. They're cute. But they're
Notice I
weird.
said human servant.
Yeah.
If you have that attitude that you're a human servant to the cat, then there's not a problem.
They're cute, but they're weird. They're some weird.
No, they're not. I would say
I had a
unique.
cat. His name was Mojo. He looks just like, he literally looks just like Garfield.
Yeah.
And every morning I wake up and he's like this. I turn over and he's just staring at me, and I'm just like,
No, what he's saying is,
I'm ready.
hurry up, human servant, get up and feed me.
and he's fat too.
The whole point is, they're not what's the other guy in Garfield, the dog? What's his? Odie. Stupid. Stand dog. All right. So next, mode. Remember mode. Mode's first two letters matches the definition. What? Showed up the most. Is the mode important? No, it's really not. But be sure you can find it. It'll give you a couple of points on the test, unless you're nonsensical. Can you have more than one mode? Yes. You can have two modes. You can have one mode. You can have two modes. You can have three modes. And what are those called? This one's just called modal. This one's called bimodal. This one's called trimodal. After that, it's called polymodal, or more than one. Now, do realize that if you have three numbers that are showing up the same amount of times, you have to write all three of those numbers down. We have 22 shows up twice, 23 shows up twice, and 24 shows up twice. Then you have trimodal. It's 23, 24, 25. If 22 shows up twice, 23 shows up twice, and 24 shows up 6 times, then you have one mode. The one that shows up the most. If they all tied for the most, then they're all three the most. Okay? Do not. What number, if there's no mode, what do you not put? You don't put zeros. Because you'll always get some SA teacher go, well, zero is not even in the list. And you mean nothing. You mean no mode. You need to write out no mode, does not exist. Do not put zero, because you always have some SA teacher mark it wrong. Okay? So if you don't have a mode, you put no mode. Okay. Thank you. It's the only thing that is not calculated. Now, what happens after the mode? Well, mean, median, mean, median, mode, and then there is the range. The range is real simple. The highest number minus the what? Lowest number. Mid-range is also like the midpoint. I'm going to put midpoint. Because it's the high plus the low divided by what? Now, the range, the variance should be in your book somewhere. I don't know where it is. It's probably in where the standard deviation is. Yes, that's where it is. And they don't have a very good definition of it. I'm surprised. I did tell y'all I hate this book, didn't I? Okay. This book should really say on the front, we've dummied down this book as much as possible for stupid people. That's what it should say, because they've tried to make it too basic, and it's just it messes a lot of people up. There's a rule in here. I'll go ahead and tell you what the rule is. It's on page 387. What? 387. It's called the Empirical Rule. They don't call it the Empirical Rule because y'all are too stupid to spell empirical. So they call it the 68, 95, 99.7 rule. I have never seen a probability book not call this rule the Empirical Rule. And I've looked at least 3 or 4 different books. This book decides to change the name of the rule because evidently they don't think you know how to spell empirical. So they took the word empirical out and they call it the 68, 95, 95.7 rule. That's on page 386. It's not the 98, 97, 96 rule. It's called the Empirical Rule. E-M-P-I-R-I-C-A-L, empirical. I hope I spelled it right. But the book says I'm too stupid to do that, so you gotta call it. I hate this book. Anyway, we're going to study the Empirical Rule right after we talk about this, but I've got to get you to understand this first, and then we'll talk about standard deviation. Now, the variance is equal to the summation of x minus x bar, quantity squared, over n minus 1. And then the standard deviation is equal to the square root of the what? The variance.
We're going to do that in a calculator, especially.
First of all, I'm going to show you how to do it by hand. And it's real easy because you do it in an Excel spreadsheet. Or since you don't have an Excel spreadsheet, if you do have a computer, you can pull it up. But you have to write it out in columns, and it helps you. All right. So what we're going to do right now, before I can get to the 97, 98, 99, 68 rule, is we're going to find the standard deviation of a set of data. So I'm going to go over here. Well, what I'm going to do is I'm going to leave here, and I'm going to go to the Excel spreadsheet and put the data on the Excel spreadsheet. Now, the reason I use the Excel spreadsheet, nobody in here has had me before, I don't think. The reason I use the Excel spreadsheet is not because I'm saying you have to learn how to use Excel. Okay, I'm not doing that because some of y'all will break a handful with a banana. I mean, some of y'all, it'll take, I'm not doing that. I'm not doing that to myself. So if you know how to use Excel, that's great. You just use it at home and that's fine and everything will be hunky-dory. If you don't know how to use Excel, just think of it as another version of this whiteboard. Okay, I'm just using this whiteboard and I'm doing it on Excel to keep everything the same size so I don't run out of space on the whiteboard. Okay, don't even think of Excel as a worksheet. I just want you to think of it as a whiteboard. Okay. So I'm going to do some values for X. We'll say these are test scores. Let's say you've had 6 tests over the last semester. All right, the first one was a 75, the second one was a 77, the third one was an 80, the fourth one sucked, 75, the fifth one sucked even more, 70, and then it got easier, and you made a 92. Right, those should be 6. Well, what's the first rule of data? Put them in what? So on an Excel spreadsheet, you just highlight those, and you go up to data, and you sort. Just hit this button. You don't have to sort. Just hit the A to Z, and they're in order. Now you could do that in your head. Just with more numbers, it's more tedious. Okay. The second thing you're going to do is we need to find all the stuff that I've told you to find. Mean, median, mode, range, range, variance, and standard deviation. Okay, so the mean. Well, the mean, you've got to take and add them all up. So that's going to be equal to, you're going to add all these guys up. So I'm going to go over here and I'm going to hit sum. Okay, it's not going to do it. So I got to, hold on a second. The sum of all these guys divided by, how many are there? 6. And y'all can do that on your calculator. And you should get the same thing I got. I don't think any of y'all have a problem finding the average, because at the end of the semester, y'all well know y'all email me not about your average. You email me about where's my grade. Before you look on gradebook, you email me that. Median. Median's in the middle, so I got to take the average of these two numbers. So I'm going to highlight those two yellow, and I'm going to highlight this yellow, so you'll know that I use those two numbers. Parentheses, add this guy up to this guy. Divide by what? 2. So what can you tell me about the mean and the median? Are they pretty close? Yeah, 76 against 78, that's pretty close. That means our data doesn't have a lot of outliers. Range, mode, there is no mode. NA, at least I don't think there is. Oh, yeah, there is. 75. Range is equal to the highest minus the what? Mid-range is equal to, parentheses, highest number, lowest number, divided by 2. And at that point you stop, because you don't know how to find the variance and standard deviation, you quit the problem. Now you look at the formula. The formula says the variance is equal to the summation of x minus x bar, quantity squared, divided by n minus 1. So let's, I tell students in probability, and I tell you in 103, if you're given a formula, that's just like the directions in putting together a table. All right? If you want to suck at putting the table together, throw away the directions. If you want to suck at finding the variance, then just disregard the formula, because it tells you what to do. Now, what did I tell you x bar meant? The mean. So right here, I'm going to go here because I don't want to confuse anybody. I'm going to take out the mean right here, and I'm going to say x bar. Now, the reason I'm not putting the x bar is I got to go through and insert a symbol, and it just takes too long, and I'm not doing that. So just in your notes, that's x bar. So what am I going to do to x bar? I'm going to subtract it from what? Where is x? Each one of these guys are called what? X. That's x sub 1, x sub 2, or for layman's terms, the first x, second x, the third x, fourth x, fifth x, and sixth x. So I've got to subtract 78.16 from each one of these guys. So I'm going to go right here, and I'm going to call this column, and you need to call your column x minus x bar. because I'm following the directions of my formula. So, equals this guy, 70, minus this guy. I'm going to hit F4 to lock it. For those Excel people, you know what I'm talking about. For those of you just disregard that last statement, you have no idea what I'm talking about. And there's that number, and I'm going to copy that down. And there's your numbers. So what I want you to do right now, with your calculator, is take 70 minus 78, 75 minus 78, and 92 minus 78, and see if you get those numbers. Just so you'll know what's going on. Yes, ma'am. Okay, you can leave. I'll drop you from the class right after class is over. What do you get? The first one. What'd you get when you took 70 minus 78.16? What'd you get? Negative 8.16. What'd you get when you took 75 minus 78.16? And what'd you get with 92 minus 78.16? You should have got 13.83. Must be your calculator because I don't hit states.
It's random.
You shouldn't. All right, now, what do the directions say? X minus X bar, what? So I'm going to take this number and I'm going to what? Square it. We'll put right here, X minus X bar, quantity squared. You need to write in yours, you need to write parentheses, X minus X bar, quantity squared, excuse me. So that's equal to this number raised to the second power. And then I'm going to copy that down. Now, what does this guy right here say? Sum, meaning you add all the what? Add all the numbers up. So I'm going to add all these numbers up. I'm going to go right here, go right down here to this box. I'm going to hit the auto sum. I'm going to add all those numbers up. And that is the numerator for my formula. So I'm going to erase this. And instead of that formula now, I'm going to put a bar. And above it, I'm going to put 282.83. 282.83. Okay? And n minus 1. 1, 2, 3, 4, 5, 6. So 6 minus 1 is 5. All right, and I think most of y'all can work a calculator. I'm going to do it in an Excel spreadsheet just to check your work, check mine too. And that's equal to this number divided by 5. I got 56.56. Now I'm going to take the square root of that, so I'm going to raise it to the 0.5 power. And that's the same thing as taking the square root. Raise it to the 0.5, 1/2 power. 7.52. Now, 3 things I want you to look at. The mean, median, and the what? Okay. The mean is 78. The mid-range is 81. Fairly close. A little bit off. It's a little bit down. It's below the mid-range. So that means you got some lower numbers pulling your data down. And that lower number is what? 70. Because these two are pretty what? Close. That 70 is pulling it down to the left of C. If you had a 60 there, it'd really pull it down. Let the numbers tell you what's going on. The numbers tell us 78, 76, 81. The mid-range is like on a number line. This is the center of the number line. It doesn't really have anything to do with your data. What it does is it sets up your number line so you know where the center of the data is pertaining to a number line. So 81 is your middle of the number line. If you were plotting this, so 78 is a little bit to the what of 81? A little bit to the left. So your bell curve is not going to be on the center. Your center would be 81. So that means that your bell curve, the top of your bell curve, is a little bit to the left of the center line. You see what I'm saying? You're letting the numbers tell you what's going on. You're not just regurgitating, because that way you'll be one of those people that can't give change back at the cash register. All right? You're letting the numbers tell you what's going on. You're not regurgitating. And that 81 and that 76 and that 78 is telling you that 70 is pulling your data down more to the relationship of the center than that 80 or 92 is not doing as much as that 70 is. That 70 is really being detrimental to your data. Yeah, but the 75 is taking over that. See, the 75 is compensating for that. See what I'm saying? This side, you've got the 92 and the 80 and the 77. These numbers are okay. They're in a kind of gradual, this is kind of a cliff right here.
So the 70 and the 92 are out.
Pretty much, yeah. And what you're going to see on the next set of data that we're going to do is you're going to see this tightness become sloppy. We're not finished yet. Oh, yeah, we are. But what do these two numbers, and these two numbers are your important numbers. I'm going to color them green. No, I'm going to color them. That's not purple. That's magenta. I'm going to take this number, and I'm going to highlight that, and I'm going to highlight these numbers, because these numbers are important, because they help you set up the curve. Mean is 78, and the standard deviation is what? 8. Now, why am I rounding up? Because I'm not the human calculator. I'm not going to sit up here and try to add decimals in my head. So I'm going to round this up to 8, and I'm going to round this up to 78. I'll round it down. So 78 plus 8 is what? 86, Hubert. Thank you, class. 86 plus 8 is what? 94 here. What's 78 minus 8? Oh, y'all got that one. Good. Glad y'all got that one. I bet y'all get this one too. 70 minus 8 is? 62. Boy, y'all are quick. Now, 90% of my population is going to fall between two standard deviations. Empirical rule, this is where the empirical rule comes in. We'll get into that in a little bit. I want to do another one of these. And 95% of the population is going to fall between 62 and 94. Now, you need to learn how to do this, because you're going to be doing it from chapter 1 and chapter 2, is drawing this curve. The mean goes in the middle, you add the standard deviation on the right, you subtract it on the left. What about the third standard deviation? Well, we'll go ahead and knock that out too and tell you what that means. 62 minus 8 is what? 54. And 94 plus 8 is 102. So if you make 105 on the test, on any of the tests, on the class, that means you're an outlier. You're out there. This is outlier country. So I'm going to take my handy dandy red highlighter. No, let's go with this color. It's more transparent. That's an outlier, and outliers fall outside of how many standard deviations. So what falls in between the second and the third? The unusual. So take your handy dandy pen and put a big U right here. If it falls between the second and the third standard deviation, it's called unusual. And everything between two standard deviations is called normal. My daughter is at the College of Charleston, and I've been using normal since she was 3 years old and calling everything, 4 years old, calling everything normal. So between two standard deviations is called what? Normal. What's between 2 and 3 standard deviations? Unusual. And what's outside unusual? Your 6-foot second grader. Okay? Outliers. Now that's based on your empirical rule, your 97, 98, 66 rule. That's what that's based on. So be looking at that, because that tells you what I'm telling you. Now let's throw some more test scores up there. Let's say that you're in a class that you don't have any clue what's going on, okay? And you have the following scores. The first score, you flunked. You made a 50. And then you started to read, you started to study a little bit, but you still didn't do too well. You made a 70 on just about all of your tests. 70, 71, 72, and then you were in a unit to where you just took a whole semester before on, and you made a 97 and a 98. Now, first thing you look at is your mean, median, and mid-range. What's going on here? Well, 76 and 71, that's not close. That's within 2 or 3 points, you're okay. 6 or 7, you got sloppy data. Let's say that you aced the last one, or let's say that you aced this one. And again, it's still going to throw a bigger curve. But look at this. Here's the median. Look at the median and the mid-range. They're still. You got some problems here. You've got 4 or 5 points here, and you've got 6 points here. You got sloppiness. All right. Now, what is this? Is this a little bit? Here's the mid-range, 75. What is your median? I mean X bar. I'm sorry. What is your mean? It's a little bit to the what of the mid-range. So that means you're a little bit heavier on your positive end than your negative end. So that means that these numbers make more of a difference than these numbers. Okay? I'm not telling you what it ought to be. I'm telling you what it is. Okay? And the numbers tell you that. And look at what happened to the standard deviation. What happened to the standard deviation compared to the previous one? It goes up. That means that these numbers are closer together or more spread out. They're further apart. Further apart is another indicator of what? Sloppy data, or non-tight data, or non-valid data. It's spread out. The more spread out your standard deviation is, the more messed up your data is. The tighter your standard deviation, the tighter your data is. And that's why you're going to see a correlation between these 3 numbers and this number right there. When this number is low, these three numbers are what? Close together, Hubert. That's right, class. And when this number is high, these numbers are going to be what? Further apart. So let the numbers tell you what's going on. Don't just regurgitate and wonder what this 6 stands for. All right? Question on that. Now that's how you find the mean and the standard deviation. Who's got a question? Because I'm gonna throw some more numbers up here, and I want you to do it by hand. All right, so let's do it. Let's say that you're in this class, and this class is a normal class. Let's say it's not a hard class like physics or probability, but it's more like computer technology 270, and you got a 92 on the first test. Well, I don't know what I just did. Hold on. Okay, I think I fixed it. You got a 92 on the first test, a 92 on the second test, a 94 on the third test, 95 on the fourth test, a 97 on that test, and a 98 on the last test. Now I want you to take those 6 numbers, and I want you to find all the data that you can, and then I want you to graph it and tell me what it tells you. Okay? I gotta pause the video.
Let's go
Yeah,
to
at least you get twice. Yeah, let's go to Greenville and get married. Yeah.
Let's go to Vegas and get married.
Yeah.
I want Elvis Presley to marry me.
Okay, he's dead.
You know they do it in Vegas, though. It's like the Vegas.
All right. So when you got that, look at these numbers. Now look at your 3 numbers. What are they?
I'm way off on all that information.
Yeah, you pretty much need to quit.
Ooh, yeah,
I
there.
didn't get the, how did I not get the mode right?
Yeah, the mode.
Yeah,
No, the mode I didn't put because I don't care about it.
I was gonna say, I got 90. Did you get 92?
Yeah.
I don't care about the mode. If y'all can't get the mode, then okay, 92. There's the mode.
Okay.
All
That's
right.
better.
So look at your numbers. 95, 95, 95. So now you can say that the data is tight. This data is real. Now, since the data is tight and these numbers are close, let's look at the standard deviation. High or low? Low. That's the correlation you're always going to see. Different numbers in the center mean higher numbers on the standard deviation. Same numbers in the center mean low numbers on the standard deviation. So when you look at this data and you calculate this data, you're not just saying, oh, X bar is 5. They don't tell you anything. Now, when you use the calculator, what time's class over so I'll know?
35.
12:45 or 35? Don't lie to me. 35. Okay, I'll go ahead and take the roll. When you do it in a calculator, it's going to give you the same thing. And I'll show you how to do that Wednesday or so. Okay? Whatever time's next, you'll come back.